Okay, now we are moving to the data cleaning and preparation part. Now, when we look at data cleaning, this is like one of the most critical part when you want to prepare your data for data science. Now, the database guys or the data engineering team, they'll give you an NaN or they'll give you some crazy data, but they don't understand the column type, the row type, what kind of data should come by. They don't do any check. If you have a categorical data which has male, female, and suddenly beside male, female, it shows, I don't know, X, Y, Z or 1, 2. The data engineering team does not care about that much. We are on our own to find those kind of stuff as a data scientist. Uh, Now let's see what we are going to do in this section. In this section, we are going to see how to clean data, what are NaNs, how do we get NaN, remove the NaN, some of the things like threshold-based NaN removal, and inputting the values. So the first block here that I start with is importing NA. NA is a missing term that we often use. So we have to import NA, and then I create this data. And once I create this data and I print this data, it has got a lot of NaN. And when I say that I want to drop all the NaN, I have to just write drop NA, and it's going to drop all the NaN. That is the first thing to stop. Like, I don't want any NA. Just remove the columns wherever you see NA. This, however, is going to become more complex when you are going to deal with data frames. We could also do this in a way where we find out the true false thing of not null and then put it inside. So what this does is it gives me a true false thing, and it only takes in the true one when I do this. So this is another way, like taking not null and then taking the true for that. Let's see how the same thing goes into data frame. So I'm creating a data frame. I'm creating a clean data frame and the data frame. So this is the data frame. When I say cleaned, it's going to drop NA, and wherever it see even one NA, it drops the whole line, which is not a good signal for us right now, that it dropped all the lines where it saw at least one NA. We would rather be careful about that. So this is like how equal to all. This is it's going to drop only where it see all NAs and not anything else. We are going to create, when we say data 4, it means that it's going to go to the fourth one and this whole column, and it's going to put that as an NA. And when I do axis 1, you remember axis 0 and axis 1 is only changing the way in which we do the operation. So axis 1 is column wise, axis equal to 0 is row wise. So when I say axis 1, it drops the column 4 because it is made up of all nulls. Then we do import numpy as np data frame. Try to put some crazy NAs in between. Let me show you what is the data frame. So this is the data frame that it looks like. If we don't give any column name or heading name, it automatically puts that, and then we create these artificial things. So we are saying that go from 4, go till 4 and the first. So 0, 1, 2, 3 and the first one, implicit location. So 0 and 1. So make all of this as NA. And here we are saying that go 0 till 2, not including 2, 0 and 1, and make 2, only 2, 0, 1, 2 as NaN. So the first thing makes these 4 NAs and the next one makes these 4 NA. And when I do drop NA, it's going to drop even where it sees at even 1 NA. When I do threshold equal to true, it's going to drop only if it has 2 or more. That's my threshold. So this is the use of threshold in our way. We could also fill the NAs using forward fill. Let's see how it looks like. So I'm having this, and when I do a forward fill, all of these gets filled by 0.58. This gets filled by 0.79. So that's called forward fill. When I do limit equal to 2, the forward fill is not going to spill off or keep continuing beyond 2. We can also fill the data based on the mean. Mean already ignores the NA, and it can fill the things inside that. Now we are going to see how to map stuff and change it based on a mapping, and see the same thing using dictionary mapping, using the map function in Python, and using the lambda function. So suppose you have this kind of a data, it's city and onses, and then you want to create a mapping of each city and the god for that city. So we have 6 cities, and 3 cities have one god and 3 other cities have one god. So we created this mapping or dictionary. I'm going to convert everything to a lower. That's a defensive step just in case I sometimes mistype something as capital, or if the data is coming which is not clean. And this is a nice way to clean it, that do a dot lower. Now this is lowered everything. Now I'm going to say that this data city, which is the column which earlier had this city, is equal to lowercase dot, and lowercase this thing dot map city to god is the mapping, and it's going to, since the first 3 city belongs to the god Shiva, it's going to give that god to that city, and the next 3 belong to god Vishnu, so it's going to give it to that god. So that's how this would work. We could do the same and say lambda and say city to god, which is my mapping, and do that to what? X dot lower. So take the key and apply this key. So this is the way to do it using the lambda function or using the map function. Both gives us the same return, but lambda function is element by element applying a function. So take all the X, convert that into a lower, put that as a key inside a dictionary, and run that dictionary, and whatever is in the value is going to spit it off. So that's how we clean this part of the cleaning. So that's about how we clean removing NaN, impute missing values, and use mapping or lambda function to do some basic mapping based cleaning.